In this video, we're going to talk about finding the area. Area is the number of square units it takes to fill a two-dimensional space. Let's start out with the rectangle. So if we have a rectangle, say it's 4 inches, and let me draw this rectangle a little bit better so it looks a little bit more to scale. We're going to do a 4 by 2 rectangle. So 4 inches by 2 inches. You may remember that the area of a rectangle is base times height, which sometimes you'll see it as length times width, either way. So we take the two sides, 4 inches, and we multiply it by 2 inches, and 4 times 2 is 8. Now, in terms of units, you can get the units one of two ways. Remember, x times x is x squared, so an inch times an inch is an inch squared. Or remember the definition of area. It's the number of square units. So whatever your units are, just square them. Now, why is it that this formula works? Well, if I have a 4 by 2 inch rectangle, then I could make 4 squares across that are going to be an inch long. And if my rectangle is 2 inches high, then I can make 2 squares. So you can see I have a total of 8 squares. Well, rather than sitting here constructing these squares and counting them up, we can all see that the shortcut would be 4 times 2. 4 squares across, 2 high, 4 times 2 is 8. So our area formula, base times height or length times width. Now, let's take a look at a parallelogram. A parallelogram, actually a rectangle is a parallelogram, because to be a parallelogram, you just need to have 2 pairs of opposite and congruent sides, which is exactly what a rectangle has. But a rectangle is just sort of that one-upper. A rectangle, in addition to having the 2 pairs of congruent parallel sides, it also has the right angles. So this is just a general parallelogram. Let's say we have a base. Now, the thing about the height is that the height will always hit the base at a 90-degree angle. So in the case of the parallelogram, the outside edge is not hitting our base B at a 90-degree angle. So we cannot consider that as our height. So the height is actually this dashed line that I labeled H. The area of a parallelogram is still base times height. So let's say we have a parallelogram. Let's call this 9 inches. Let's call this 5 inches. If I want the area, it's as straightforward as the rectangle. We take the 9 inches, multiply by the 5 inches, and we get our area of 45. Keep in mind we're talking about square units, so it's inches squared. We take for granted in the rectangle that the outside edge is also the height because we have these 90-degree angles. So it turns out that the base and height are just the 2 outside edges. But in just a general parallelogram, note that that is not the case. The height is actually different than the outside edge. We're going to look at an example in class comparing the perimeter and area of a rectangle and parallelogram, and we will do that in class. Let's continue on with area. This time we're going to look at the area of a triangle. Let's start out with a rectangle. If the rectangle has base B and height H, then the area of it we know is base times height. If we draw in the diagonal, what we actually construct are 2 congruent triangles. back in a high school geometry class, you probably proved that these two triangles were congruent. We're not going to worry about proving that here, but what I need you to understand then is if these two triangles are exactly the same size, then one of them is half of the entire rectangle. In other words, the area of a triangle is 1/2 base times height. So we're talking about triangles here. So the area of a triangle is 1/2 base times height. Let's take a look at just a couple of examples. Let's say that this is 8 centimeters, this will be 6 centimeters, this is 4 centimeters here on the left, and we have this drawn in here, which is 7 centimeters. So we see we have a triangle, we know the area is 1/2 base times height. Problem is, I only need 2 numbers for my formula, and yet I have 4 of them present. So we need to make sure we know which ones to plug into the formula. If you're thinking that 8 is the base, well, be careful, because you don't see any other segments that hit that side of 8 centimeters at a 90-degree angle. Remember, anytime you are looking for the base and height, you are looking for that 90-degree angle. So in this case, we're going to let 6 be the base because we have that length of 7 hitting it, or that segment that is 7 centimeters hitting it at a 90-degree angle. So always look, when you're looking for the base and the height, always look for the 90-degree angle. All right, carrying out this calculation, 6 times 7 is 42, and half of that is 21. Remember our units, area is always squared, or a centimeter times a centimeter is a centimeter squared. Let's take a look at one last triangle example. I'd like you to pause the video here and find the area of this triangle. Okay, welcome back. Hopefully you didn't end up with 78. If you did, you fell into that trap of just plugging in the numbers you have right into the formula. But the numbers that are given are not necessarily always the numbers that you need. In this particular case, we need the base and height because we're asked to find area. Remember, the base and height always form the 90-degree angle. So we do not have the lengths of the two sides that form the 90-degree angle. We only have one of them. But we do have that good old Pythagorean theorem. Since we have a right triangle, and we're missing one of the sides in the right triangle, we can apply the Pythagorean theorem to find that missing side. Now be careful when you plug into the Pythagorean theorem. You may be tempted, sure, 12 goes in for one leg, here it is, but you may be tempted to plug in 13 for the other leg. You can't do that. Okay? You have to make sure you plug the numbers in for what they are. 13 is the hypotenuse. The two legs always form the 90-degree angle. So in this case, we are actually missing one of the legs. 13 will go in for the hypotenuse value. Now this requires a little algebra to solve. I'm going to start out by squaring 12 and squaring 13. Okay, to get x by itself, I'm going to first subtract the 144 from both sides. X squared is equal to 25. Okay, but I just need x, so I'll square root both sides, and I find that x is 5. If you happen to pick up on the fact that this was a Pythagorean triple and you just knew that that other leg was 5, that's fine. All right, so now we did a whole lot of work, but we have yet to answer the question. The question is, what's the area? We finally have enough information to find the area. Half of 5 times 12 is 30. And in this case, I forgot to put units on there. So we can just call it square units. All right, just general units. So if you're ever missing units, make sure you put the correct, whether it's the linear unit, the square unit, or the cubic unit, as we'll be talking about in volume later on. Okay. All right, moving on, we're going to move on to